Hello, we are back with another video. This is number 17 in the AP Physics C Mechanics multiple choice test. So this one has a long introduction. It looks like it's a set of 3 questions. So let's get into it. The situation here is a solid disk of mass m and radius r freely rotate horizontally in a counterclockwise direction with an angular speed omega about a vertical axis through its center with negligible friction. The rotational inertia of the disk is 1/2 mr squared. An identical disk is suspended initially at rest above the first disk with their centers aligned. The second disk is dropped onto the first disk, and after a short time they rotate counterclockwise together with the same angular speed omega final. Question 17 asks us which of the following properties of the two-disk system are conserved. Answer A is kinetic energy only. Answer B is only angular momentum. Answer C is both kinetic energy and angular momentum. D is neither kinetic energy nor angular momentum. And E says it cannot be determined without knowing the forces between the two disks. So let's take a look at the topics that this question relates to, discuss them, and then move into the problem. I don't really have any space to write here, so I'm just going to talk a lot for this one. So, let's talk about the collision that's going on between these two disks, because that's really at the heart of what this question is about. We're asked to analyze angular momentum and kinetic energy, and to do that, it's important to look at whether this collision is elastic or inelastic. Inelastic, a perfectly elastic collision, that is one where no energy at all is lost. So momentum is conserved and kinetic energy is conserved. This is rare in nature in real life because there's usually energy lost to something, whether it's light, heat, sound, vibration. There's all these things that energy is lost to in collisions. This collision is a perfectly inelastic collision. Inelastic collisions are when energy is lost, and this is a perfectly inelastic collision because these two disks stick together. Sticking together is kind of a hallmark of a perfectly inelastic collision. So because these disks stick together, we know that it's a perfectly inelastic collision. Because of that, we know that there is kinetic energy loss. So that can help us eliminate some answers. So which are conserved? Not kinetic energy only, that's lost. Both kinetic energy and angular momentum? No, because it loses kinetic energy. Alright, so that leaves us with B, D, and E. So now let's talk about angular momentum here. So, angular momentum is always conserved unless there's an external force added into the system. So in this case, it defines the system for us as, let's see, what does it say? We're talking about the two-disk system here. Which of the following properties of the two-disk system? So if we define this system as just the bottom disk that the other disk is being dropped onto, then yes, angular momentum would not be conserved. But since the system is defined as both of these things, angular momentum is conserved because there's no external force introduced into the system. These are already a part of the system at the start. So angular momentum therefore is conserved. So we can't say this because angular momentum is conserved, and we have just determined that only angular momentum is conserved. Alright, well done. So we figured it out to be B, kind of by talking through elastic versus inelastic collisions and kinetic energy and angular momentum. Let's see. Yeah, a pretty straightforward problem as long as we take into account, again, what type of collision it is. That's the key in this problem, to analyze the fact that they're sticking together. They rotate counterclockwise with the same angular speed. So if we're talking about conservation of angular momentum, we can write that out as I W. So I of, we'll just call this 1 plus I2 is equal to I think you would add the i's here. Final. So that's an equation we could use to represent the momentum here. But in reality, we don't have to have equations in this. We can really just think this one through. But if we had to, we could write that out. Yeah, thank you for watching. This is about angular momentum. This is about collisions, elastic versus inelastic. Let me know if you have any questions. Thank you for watching, and make sure to check back in for the next video.